right? So I can draw figures on the screen at the moment. So let's do rectangle maybe. Hey, welcome to day 47 of 100 Days of Code in IoT Challenge. I'm Thomas, and this is the channel that educates you on IoT and web development by showing how to build projects step by step. For more content like this, make sure you subscribe so you will be first in line when it comes to the channel updates and new videos. And now, let's get started. So today, I'm gonna start a new project that is gonna be a Nokia 3310 style snake game on a microcontroller with TFT screen. The plan for that project is to build it step by step. So for the next couple of days, I'm gonna keep uploading videos where I add functionalities to it until we have a full working game. And today, for the first step, as always, I'm gonna start with the presentation of the hardware components, and then I'm gonna show you how to assemble the circuit. So let's move to the breadboard view. So here I have all the required hardware parts. Let me just quickly go through them. So we've got ESP8266 microcontroller. That's gonna be our control unit. I've got a TFT screen, 1.8 inches. And the resolution of the screen is 160 by 128. The model should be visible on the screen right now. That is gonna be to display our game. Then 4 buttons, right, up, down, left, right to control the snake. A resistor, this one is 10 kilo ohms resistor. It is needed for pin D0 to create a pull down resistor. USB to micro USB cable to connect microcontroller to my computer, and wires, this type of wires, this type of wires to connect everything up and to make this circuit as visible and easy to understand as possible. But yeah, let's see how it goes. And now, before I'm gonna start assembling it, I'm gonna show you a circuit diagram because it's gonna be easier to understand for you how this is gonna be connected. Okay, so what I've got in here is how to connect TFT screen to the microcontroller, and I've also got this pins map, right? On the left hand side, we've got the pins on TFT screen, and on the right hand side, the pins on the microcontroller. So this is how you need to connect them together. And yeah, I'm just quickly gonna go through them. So I'm gonna start from VCC, right? It starts from left on VCC and ends on LED, right? And VCC is going to the plus rail of the breadboard that is connected with 3v3 on the microcontroller. Then we have GND, ground, that goes to the minus rail of the breadboard that is connected with the ground pin on the microcontroller. And then CS, this wire connected to D8 pin, then purple wire, which is a reset that goes to D6, gray wire going to D1, that is A0, then SDA, which is a yellow wire going to D7, SCK going to D5, there is a green wire in here, and finally LED also connected to the plus rail as the VCC that goes to 3v3, right? So that's how you connect TFT screen to the microcontroller. However, this is not everything because we also have the buttons on the breadboard. Let me show you the next slide. There we go, okay? Here it looks a bit more complex, right? But don't worry. On the TFT screen connection with ESP8266 controller, nothing really has changed. It all stayed the same. The only thing is those additional connections to the buttons, right? And what I'm gonna do for those is to start from pin D0. This is the blue wire in here. That goes to one side of the button. And notice that this is also connected with the pull down resistor that goes to the plus rail on this breadboard, which is connected with the plus on the other breadboard, right? So this all comes from 3v3, right? So we have 3v3, and that 3v3 allows us to pull down, to use the pull down resistor on this side of this button, right? That is connected to D0. And the other side of the button just goes to the ground, which again is connected with the ground of the other breadboard that ultimately goes to the ground of the microcontroller, right? So that is the most important pin because it contains something extra. And that is a down button, by the way. Okay, now pin D2, there is the pink wire that goes straight to the one side, right? The bottom side of this button, and the other side of the button going to the ground. And this is actually the same for all of the buttons, right? So this was a right button, that is D2, then D3 orange wire going to one side of the button, other side going to the ground, which is a left. And finally, this sort of brown right wire is going to the up button and the other side of the button going to the ground, right? So it's not as complicated as it looks on this picture. And I've also added this note in here so you can see how those pins are mapped, right? So we have D0, which is down, right? D3, that is left. D4, that is up. And D2, that is right. Okay, so that's how it looks like. And this is exactly how I'm gonna connect it, but on my breadboard is gonna be a bit more complicated, I suppose. Let me quickly assemble it and then we move to the code. Here is my Visual Studio Code already opened. And I'm going to start from going to PlatformIO. There's an extension required to develop code on ESP8266, by the way. And I'm gonna go to Quick Access and Open. And in a new tab, New Project. And let's call it a Snake Game. Then the board. The one that I'm using is Node MCU 1.0 ESP12E module. And I'm gonna click on Finish. And there we go, the project is opened. And I should see platformio.ini to open automatically in a few seconds. There we go, there we go. Okay, let me zoom in for you. Nice, right. Here there is one setting that I'm gonna have to set, which is the monitor speed. And that's gonna be the value I set it to. And I'm gonna copy this value and go to the SRC main. And in the setup function, I'm gonna type serial begin and paste that value. And after that, I'm gonna do delay of 2 seconds. That is to initialize serial monitor and to let the device catch up with IDE to send the information to us for us to be able to debug. Right, okay. So yeah, that's the initial setup. However, it's not finished because we need external libraries. So I'm gonna go back to PlatformIO Quick Access Open, but this time to Libraries section, and I'm gonna type GFX. That's the first library I need, Adafruit GFX. So I'm gonna add it to the project. That is a Snake Game, and add. So yeah, GFX is the first one. Then I need bus.io. Adding it to project. And the last one, which is ST7735. That's the model of TFT Screen, and this is the one, this is the library I'm going to add to the project as well. Snake Game, add. Right. If you don't want to click and install all of them like manually, like I've just done, you can instead use the platformio.ini and just type in libdeps and all of these 3 dependencies to your project, just add them. Cool, okay. So yeah, with those libraries, now we can display some information on the TFT screen. But in order to do that, there are a few includes I have to add. So one is wire, another one is SPIH, then we need GFX, Adafruit GFX, and the one for our screen, which is Adafruit ST7735. Okay, so with those includes, we should be able to print something on the screen. Okay, but that's not everything. Now I need to create an instance of that particular screen, which is that one, and let's call it TFT. That constructor needs a few arguments, and those arguments are actually the pins. So let me show you what kind of arguments we need to define in here. So we've got TFT CS, TFT RST, that's the reset pin, and the last one is TFT DC. We had more pins, right? There was 8, 3 of them connected either to the ground or the 3v3. So there is one missing, I guess, or it's 2 missing. It's probably 2 missing. No, it's 1 missing. But this one we don't have to specify because it's a default one that Adafruit SST7735 is gonna detect automatically. Okay, and now what values should we put in here? So we've got CS, and we can do it based on this map, right? So CS is D8. Okay, CS is D8. So I can just type D8. Then reset is D6. Reset is D6. And DC is A0 in our case. Okay, so that's gonna be D1. D1. And then I'm gonna just pass them to the constructor of Adafruit ST7735. That is the order of things, by the way. So it's not exactly like I defined them. Right, so we've got that done, and now I can initialize the screen. So there is a specific method to do that, and it's called initR. For my type of screen, that's gonna be initR blacktop. So basically, if your screen, if you bought a different screen, like slightly different screen, and you try to init with this, with initR blacktop, and you will get some incorrect, especially at the edge of the screen, you will see some incorrect pixels. That means you probably did the init with the wrong argument. So try different ones. There is a blacktop, green, or red, and others, right? So it's a good idea to have a look at that if you get some weird edges with some weird pixels, okay? Right, so that's first step, and now I'm gonna fill the screen with black color first. So SST77 black, right? Great. So we're gonna get a black background on the screen. Another thing that is quite important is the rotation, set rotation. So that also depends how did you connect the screen, like in what way you connected it to I mean, it's not really how you connected it, it is how it is presented on the breadboard, right? So in my case, it looks like that, right? And because it looks like that, have a look here, the pins are on this side, right? And for this configuration, for this position of the screen on the breadboard, the best rotation, something I checked beforehand, is 3. Right? There is 0, 1, 2, 3, and always rotates by 90 degrees. So that's gonna be the option to experiment with to get the right rotation on the screen. And yeah, this is essentially it to set it up. And now we can start, we can start writing text, we can start adding pixels and so on. But our goal is to build a snake game. Today, my focus is more on the hardware, right? So how to connect everything and how to just make the screen work. So that's the goal of today's video. However, I'm gonna do something extra, just a little extra, and we're gonna draw a pixel. We're gonna draw a pixel in the middle of the screen, somewhere in the middle of the screen, and with those buttons that we have connected, we'll be able to, by pressing the button, to add another pixel on the screen from the point where the last one was added, right? So yeah, let me show you, let me demonstrate how this is gonna work. But for that, we're gonna use the buttons, and to use the buttons, we need to set them into the right modes, okay? So we've got D0. This one is important because that's gonna be a different mode, which is input, right? We've built our own pull up, right? We build a pull up resistor there. Then we have D3, and that is input pull up, D4, and that is D2. So actually it's better to do D2, D3, and D4. So all of those pins are gonna be input pull up, except for this one, but this really is also pull up, okay? That's also pull up. But I did it myself with the resistor because it needs I think it needs a stronger resistor with the higher resistance to make it work. That's why, because yeah, I tested it with the input pull up and it didn't work. Only if you add your own resistor, you can control this pin. So nice. So we've got those pins covered. Let me create a helper function now that returns a boolean that is gonna be called is button pressed, and that's gonna take uint 8t, which is gonna be a pin, and that is gonna just return the result of the digital write comparison with low, right? Because that means if low, that means the button is pressed. Another thing to slightly improve readability, I'm thinking maybe I should define those pins here as the actual directions, right? So we have like a left, right, up button and so on. Let me have a look at this picture again. So we have D0 is down. So let's do down button, D0. Let me speed it up and do the rest. Okay, done. And now let's swap them accordingly here. So that is D3 should be this one, D2 is this one, and the up button is this one, right? So now we're gonna operate on buttons instead of D1, D2, D3, so that's not gonna be as confusing as it used to be before. Okay, right, so in the loop function, this is where the functionality is going to be implemented. However, what we need first is to build add a struct. Okay, I'm gonna need to add a struct. I'm gonna call it point. So we will have struct point. That's gonna be our pixel on the screen. And let's just give it uint 8 for x and uint 8t for y, right? And let's create an instance of it. So we'll have point now. And here in the setup, let's set x to 80, right? There should be somewhere in the middle, and y to 64, right? Because the screen is 160 wide, so 80 is half, and the height is 128, so 64 should be the half of it. And now that point is gonna be what we display on the screen. So I'm gonna do draw draw, that should be draw pixel, something like this. Draw pixel, yeah, there we go. So draw pixel, and that pixel is gonna be px and py, and the third is the color. So let's pick a color, maybe white, so we just write white on a black, but yeah, you can pick any color you like. Yeah, and that's gonna happen at the end. That's gonna happen at the end of the loop. And before that, this is where I'm gonna put the if statements for the buttons, right? So if is button pressed, it's gonna be as simple as that. So if top button, it's up button. If up button is pressed, then what's gonna happen is we're going to increment, or rather decrement, y, right? Because, you know, if y is 64, we wanna go one level up, right? One pixel up. Then decrementation is what we need. For down button, what we're gonna have to do is to do the opposite, right? So we're gonna increment y, right? It's going down. So the y increases. I think it's sort of other way around than you would have it on the actual, you know, x and y axis in maths, right? You start from 0 and it grows as you go up, right? And then decreases as you go down. Here is slightly different because 0, 0 is the left top corner of the screen, right? Okay, let me add another one. So now it's gonna be left button. So if left button is pressed, now what's gonna happen? We're going to decrease X, and we're gonna do opposite for the right button, right? So there's gonna be px++. However, that's not the code I'm gonna deploy because there is something missing in here, which is not gonna be perfect. But for today's example, this is fine, because if I keep it like that, you probably remember, or if you're not, I'm gonna remind you. So loop function executes, I think it's more than once, it's probably more than 10 in 1 millisecond. So if you keep it like that, pressing any button is gonna draw a whole line to the end of the screen. And that's not something we want to do. We want to see, like, you know, pixel by pixel. So what I'm gonna do, a quick fix for now, but that's not really what's gonna happen with the snake game, because with the snake game we really care about the transition of the state, but that's gonna be the next video tomorrow or the day after tomorrow. So for now, what I'm gonna do is to just put delay here, right? We put delay here, or even better, you know, instead I can just put a single delay in here, right? So we'll have delay 100 milliseconds. And that should limit us to 100 milliseconds of time before the next pixel can be drawn, right? And I think this is pretty much it. What could be good to do is to draw that pixel maybe in here first. Not sure if this is required though. You know, it's actually not, because it's gonna draw it anyway. At the beginning, the buttons are not pressed, so should be fine. Okay, yeah. So this is the sketch for today, and I'm going to deploy it now, so we shall see how that works. Okay, yeah, I've made a mistake, small error. You may have spotted it. I'm definitely gonna add the text. That should be digital read, not digital write. Okay, program deployed, and we should see something in a second. There we go. So there is this small pixel in the middle of the screen. It might not be visible at the moment, but I'm gonna press the up button, right? And we can see I'm just drawing a line on the screen, right? So at the moment, as you go to the next pixel, the previous one is not deleted, right? It just stays on the screen. So now I'm gonna go left, and it goes left, right? And down. There we go. Right, so I can draw figures on the screen at the moment. So let's do rectangle maybe. And here we go, right? Yeah, there is one thing that we can notice here. When I press, I think when I press the up button, the blue diode on the ESP8266 lights up. And I think, yeah, when I press bottom one, then we have a red one, right? This is just a side effect from the digital pins these buttons are connected to. But it's not really affecting anything here. We just get a light, right? And left and right there are no side effects. Cool, okay, so yeah, so that was the first step. And this is it for today. Thanks for watching. Tomorrow I'm gonna draw an actual snake on the screen. I'm gonna make it move and we're gonna control it with the buttons. If you find my content useful and you would like to stay up to date with my channel, don't forget to subscribe. The button is somewhere there. Cheers, bye.